Okay, I want to show you for a few minutes the concept of scientific notation. Scientific notation is used when we're writing really big numbers or really small numbers, which makes sense for science, right? Because they're measuring the distance between planets, which is huge, or microscopic organisms, which are teeny tiny. So it could be really unwieldy if I'm writing something like a big number like this. Now I can read that. That's 396 million. But we're going to get bigger in a minute. Here's the principle of scientific notation. Very straightforward. The number is written with just one digit to the left of the decimal. One digit to the left of the decimal. So I'm going to have 3.96 times a power of 10. And my power of 10 is figured just by how many places I moved my decimal. So remember 396 million has an understood decimal at the end of it? So I would go 1, 2, 3, 4, 5, 6, 7, 8 places to that. So it's 3.96 times 10 to the 8th. All right? And it really makes sense. Let's suppose I had 400, a number that we could deal with, right? Well, I told you I'm going to put my decimal right here. So I start with 4 is where I want my decimal, and I moved it over 2 places, which would be 10 to the 2nd. What is 10 squared? 100, right? 4 times 100 is 400. So that's the principle we're applying. With smaller numbers, though, it's obviously, we don't need it. But if I was trying to deal with something huge, like, let's go even bigger than this. Let's say something that. I won't even try and pronounce it, right? Well, where's my decimal going to go? I want one digit to the left, so it's going to go after the 4, correct? Yes. So I'm going to have 4 point, and then whatever else I have, 329. So now I've got to count my way back. So I'm going to start here where the decimal is at the end. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 places. So it's times 10, whoops, times 10 to the 12th. So that would be a much easier way to write it, and especially they're getting up into things, that are much larger than that, 10 to the 23rd, things like that. But the key thing is there'll only be one digit to the left of the decimal. So if they give you a problem and you solve it, and if they give an answer like 93.2 times 10 to the 5th, I can rule that out immediately because that's not in scientific notation. Scientific notation, it has to be over one more decimal. I'll tell you, this number is the exact same thing as 9.32 times 10 to the 6th. They equal the same thing. You could try it on your calculator. But the key thing is, this is not in scientific notation. If they ask for my answer in scientific notation, it must be like this, with only one digit to the left. Now let me show you if you're dealing with something microscopic. The principle is the same. Suppose I've got some little organism that is that tiny, okay? And I want to write this as scientific notation. Well, that is going to be, I'm going to write it down here below. Where's my decimal going to go? Right there after the 6. Because remember, one digit to the left. And I just count the number of spaces I move my decimal. 1, 2, 3, 4, 5, 6. I moved it 6 places. Now here's the catch with teeny tiny things. It's a negative exponent. So it would be 10 to the negative 6. Okay? 10 to the negative 6. And let's just run through that really quickly. If you remember, with with negative exponents, if I had 3 to the negative 3, remember that means, that negative sign I told y'all means it's the reciprocal, which would be 1 over 3 to the third. If we solve 3 to the third, I'm just telling you it's 27. 3 times 3 times 3. So your answer would be 1 over 27. I'm just reminding you, we know that actually, right? We know that the negative decimal means that we take it down into, we do the reciprocal. So think about it here with scientific notation. It just makes sense that that made it a fraction, right? That this is going to make it a fraction or a decimal. It's going to be less than 0. So let's try one more together of a really small number. 0, 0, 0, 0, 0, 0, 3, 9, 4, 2, 7. And you want to write it as in scientific notation. The decimal is going to go with 1 digit to the left. So I'm going to have 3.9427, okay? 1, 2, 3, 4, 5, 6, 7. I moved it 7 places. And remember, we're talking microscopic, less than 0, so it's 10 to the negative 7. Your calculator does some of the scientific notation stuff for you, but if you understand this basic principle, you're in good shape. And again, I want to remind you, only 1 digit to the left. Every time I've seen a practice test question, they've had some answer that's maybe 37.4, or I'm not making that up, but 37.4 times maybe 10 to the 15th or something like that. That is not in scientific notation because I can only have 1 digit to the left. So if they want it in scientific notation, rule that one out quickly, because it's like, well, that can't be right because it's not in scientific notation.